at bond formation and bond breaking. For reactions to happen, for reactions to occur in organic compounds, new bonds are formed and bonds are being broken. For example, when you have a reaction between one thing or the other, for the reaction to happen, there will be a breaking of that bond and then there will be a formation of a new bond. Okay? So the question is, how is bond being formed in organic chemistry? Now, the question now you have to ask yourself is, what do carbon or elements that are involved in organic chemistry, what do they use to form a bond? They use their what? Orbitals, right? Now, what are the orbitals present in carbon? From what we have looked at before in tetravalency and catenation, you will see that carbon has the s orbital and the p orbital only, okay? So this overlapping of this s orbital and this p orbital will lead to the formation of bonds. And there are two types of bonds you need to take note in organic chemistry. The first one is what we call the sigma bond. The sigma bond, which is denoted as this. While the next one what we call the pi bond, which is denoted as this. So these two bonds are being formed whenever orbitals overlap. Okay? So since carbon consists of just s and p orbitals, the overlapping of these orbitals will lead to the formation of these bonds. How do these bonds form from the overlap? Now, when you have an s orbital overlapping with another s orbital, when you have another orbital overlapping, s orbital overlapping, the bond formed here is a sigma bond. Take note. The bond that is formed between these two is what we call sigma bond. Okay, so also when this s orbital overlaps with p orbital, the bond, remember this is S, this is p, the bond also formed here is a sigma bond. Now, when two p orbitals overlap linearly, the bond formed here is also a sigma bond. So when we look at this overlap here, this point of overlap here between these two p orbitals, the bond they are saying here is a sigma bond. Now, the question is now, since sigma bonds are formed between this and this, how do we now get the pi bond? The pi bond is not actually an overlap. It's actually a kind of a force of attraction experienced between two p orbitals in phase. Two p orbitals in phase. Okay? So this is in phase. They are in phase. In phase. Or you can use the word vertical. Or you can say they are vertical. So this bond experienced here is what we call the pi bond. Take note, the sigma bond is stronger than the pi bond. Why? Because these ones are actually interconnecting, they are interlinking. So it will be difficult for you to break this bond than to break this one. So it's very simple to break, okay? So that's why during reactions, these pi bonds will easily break and then they will quickly leave as a nucleophile. So now, what it means is that, in summary, what we have done so far is that you have to understand that every carbon to carbon, every carbon to hydrogen, every carbon to oxygen single bond, every oxygen to hydrogen single bond, every carbon to halogen single bonds are all sigma bonds. They are all sigma bonds. Okay? While carbon to carbon double bond, carbon to carbon triple bond, carbon to nitrogen triple bond, out of all these bonds, carbon to oxygen double bond, out of all these bonds, one of them is pi, one is sigma. One is pi, one is sigma. Two are pi here, then the one here is sigma. Two are pi, the one here is sigma. So in every double bond, I have one sigma and one pi. In every triple bond, I have two pi and one sigma. For example, what if you're asked how many sigma and pi bond are in this compound? How many sigma and pi bond are in this compound? Now, for us to find how many sigma and pi bond in this compound, I will have to show how this carbon is connected. So from here, this carbon is having one hydrogen here, one here, one here. That is CH3, which covers this, connected to carbon, which is triple bonded to carbon. Okay, connected to carbon, which has one bond to hydrogen, double bond here to carbon, and one other bond to hydrogen, single bond to carbon with 3 hydrogens. Okay, so now how many sigma bonds are you seeing? Remember that all the single bonds are sigma bonds, so we can count it. 1, 2, 3, 4. Out of these 2, 1 is sigma, so 5, 6, 7. Out of these 2, 1 is sigma, 8, 9, 10, 11, 12, 13. So I have 13 sigma bonds. How many pi bonds do I have? Out of these triple bonds, 2 are pi, so 1, 2 is pi, plus another one here is pi. So I have 3 pi bonds. So inside this compound, I have 13 sigma bond and 3 pi bond. Now take note, if you are being asked to find the electron, how many electrons should be in a sigma bond, in this sigma bond? If you have one sigma bond, one bond like this contains 2 electrons. So if one bond contains 2 electrons, it means that out of this sigma bond, 13 times 2 will give me 26 sigma electron. While 3 sigma bond will give me 6 pi electron. So take note, if you are being asked to find the number of electrons in the sigma bond you have gotten, multiply it by 2, it becomes a sigma electron. If you are asked to find the pi electrons means the sigma pi bond times 2. So pi bond times 2 will give you 6. So you have 6 pi electrons but 3 pi bonds. We have 13 sigma bond but 26 sigma electrons inside this compound. So this is how we calculate sigma bond and pi bond inside a molecule.